Okay, hello again everyone. This is the fourth video in the vector series. We're going to look at vector geometry. Basically, really important idea. These three vectors are all p because they're the same length and the same direction, so we can designate them as the same vector. That's going to be really important in what we do. Notice it's small letter p. It's not start and finish points like AB or PQ or whatever, but small letters. Here's a little example. Here's vector P, same as before, and vector Q. If we take another vector, here's 5 other vectors, we can designate them in terms of P and Q. For example, this one is the exact opposite direction of Q, and it's twice as long. So it's negative 2Q. This one is the opposite direction of P and twice as long, so it's negative 2P. This one is the same direction as P and 2.5 times as long, so it's 2.5P. This is negative 0.5Q. And this is 1.5Q, I believe. Yes. Okay. The other important thing to notice about vector geometry is that AC, vector AC, starts at A and finishes at C. That's the same as AB plus BC. Because if you start at A and finish at C, you can get that directly along AC, or you can take 2 steps to go from A to B and then B to C. So this always works. So you can imagine if you want to get a vector AC, if you just cover up the plus sign and the 2 B's, you can see that you've got AC. Same here, EF. If you cover up the plus sign and the 2 G's, you'll get an EF. Alright? You can put any letter you want in there too. Like AC is also AD plus DC. It's also AW plus WC. Okay, so that's an important thing to remember. We're going to look at a few examples now. First couple of examples, we're going to use this parallelogram. Okay, so we've got parallelogram OPQR. That's important that the numbers go in alphabetical order around the parallelogram. Sorry, the letters go in alphabetical order. OPQR. OP is small vector A. OR is vector B. But QR is the same direction, RQ is the same direction and the same length as OP. And OR, well, PQ is the same direction and the same length. So OQ, the diagonal there, to get from O to Q, you can go OP plus PQ, so that's A plus B. You can also go OR plus RQ, so A plus B. Okay, just think of it as O to Q, you can get there going O to P and then P to Q, or O to R and then R to Q. Either way, you'll get there via A plus B. When you add 2 vectors together, what you get is called the resultant. Here's something a little bit more tricky. We want to find S, which is the midpoint of PQ. Same setup, same parallelogram as before. We want to work out vector OS, which means starting at O, finishing at S. Well, to get there, we could go along A, so along OP, and then PS. And PS is half of PQ, which is A plus half of B. But of course, there's another way to do it. We start at O, then go to R, and then go to Q, and then go back to S. So we've got OR is B, RQ is A, and QS is half as long as B in the opposite direction, so it's negative a half B. Simplifying that, you get half B plus A, you get A plus half B. Here's another example involving a midpoint. We've got a triangle ABC. The midpoint M is the midpoint there. AC is P and AB is Q. Find BC. Okay, well BC is BA plus AC. BA is negative Q and AC is P, so it is P minus Q. Carrying on this example, we need to find BM. BM, that's just half of BC. So it's half of what we had before. Okay, taking this a step further, I want to find AM. Well, AM will be AB plus BM. And BM is half of BC. And BM is what we just had in the last question anyway. So, simplified, there's our answer. Fully simplified, there's our answer. Factor form is always better. Right. New question. No, same question. This time AM. We go the opposite direction. AC. And then CM. So this time CB is negative BC, so you've got to switch the signs around there. And that's it. Stay tuned for my next video.